All right, welcome. We're going to get some more practice with conditionals and some Boolean logic today. We'll look at how do you kind of have multiple conditions to check, not just like if else, if else, if else, but how do you check for more than one thing, and then a couple of Boolean things we can do, some Boolean logic. Okay, so if you want to execute code based on several conditions, you can nest an if within an if within an if as many times as you need to get all the conditions that you want. So the syntax of what this looks like is you have your first test, and then you have a second test that's inside that first test, and that code is only going to run if both of the tests pass. So you're only going to get to these lines if test 1 passes and test 2 passes. And then you could have an else within there, and this is going to run if test 1 passes. So we pass test 1, but we fail the second test. So that's what this is saying here. Test 1 is true and test 2 is false. And then if you add an else after that, that would execute if test 1 is false. So depending on the situation that you want to be in, this might be the kind of setup that you would want to test for more than one thing. Okay, so let's look at an application. So guests at an amusement park can only go on a particular ride if they're at least 50 inches tall and they're older than 18. So maybe it's a really scary ride, and you don't want to be too short for whatever reason. Let's write code that will say you can ride if they're at least 18 and they're at least 50 inches tall, and you can't ride otherwise. So what would that look like? Well, we can make a check for their height first, that they're at least 50 inches tall, and then if they pass this test, that they're at least 50, we would also make a check for their age. Are they at least 18 years old? And then we can print out you can ride in that case. And in either case, if it doesn't pass, so if they're not at least 50 inches, then we'd print out you can't ride. Note one problem here is one problem with this code actually is that if they are a tall young person, so imagine you are 60 inches tall and you're 13 years old, where would you end up? Where would you end up? What println would execute? Okay, you're 60 inches tall and you're 13 years old. Where do you end up? So, do you pass the first test? Yes, you do. So you pass the first test, which means that you go inside this if block. Do you pass the second test? Are you at least 18? In which case, the answer is no. And so we don't execute the if, so we skip that. And then since we passed the first test, we don't actually execute this else, so this doesn't run, and so we skip down to this line. So it actually ends up not printing you can't ride if you are 60 inches and 13 years old. How would you fix this? Well, to fix this, we would actually need to include another else statement right here. So we'd have to include right here else, and then system.out.println, I'll just write s out for short, you can't ride. Can't ride. And then we would catch it all. Because if they pass the first test and fail the second, it prints out you can't ride. And then if they fail the first test, then it prints out you can't ride. And so that would catch both those scenarios. So just be careful about these kinds of these edge cases. You want to think about what are all the possible scenarios you might be in. Are you, are you tall enough but not old enough? Are you tall enough? Are you old enough but not tall enough? And so forth. Are you the right height and the right age? Those are kind of the three scenarios. Or the other case, which is you're too short and you're too young. So there's 4 possibilities in this scenario. And you gotta kind of check through them all. Will they all work? All right. So if we could have written this a little bit simpler if we use what's called and or. And what and is a way to combine 2 conditions into one. So A and B is going to be true if they're both true, and only then. So you need A to be true and B to be true. And then A or B, that's the 2 vertical lines. So and this means and the other one means or. This is or. A or B is true if A is true or B is true, or they're both true. So, or both. This is a kind of tricky one with computer science, is that when we talk about or, it's called the inclusive or, and it means A is true, or B is true, or both are true, and in that case, those all evaluate to true. So one way to get a handle on what these all mean is to write what's called a truth table. So that's where you write down all the possible values that you could have for A and B, what are all the combinations that there are, and then what are all the results for A and B and A or B with those different combinations. So this is the truth table for both A and B and A or B. So if you look over here on the left, we've got for A, we have A could be true and B could be true, and then we could A could be true and B could be false. So those are all the combinations for A being true. And then we could also have A being false, B being true, and then A being false and B being false. So there's 4 possibilities, 4 possible combinations for A and B, and that's all of them. So what does A and B look like? Well, A and B is true only if they're both true. So we need A to be true and B to be true in order for A and B to be true. And then it's false if any single one of those is false. So if A is false, A and B is false. If B is false, A and B is false. If A and B are both false, A and B is false. Okay? So this is mostly false. Okay? And then A or B is kind of the opposite, almost. It's not exactly the opposite, but it's true if A is true or B is true. It's true if A is true or B is false. It's true if A is false and B is true. And it's false if they're both false. So this is the one time that A or B is false. And so this is the inclusive one right here, inclusive part, is that if they're both true, then A or B is also true. Okay, so let's look at that last example with using the logical ands and ors. So now, if we kind of backtrack, the scenario was, oops, too far. The scenario was we needed their height to be at least 50 and their age to be at least 18 in order for them to be able to ride. So now we can combine that into one check, one condition. If height is greater than or equal to 50 and age is greater than or equal to 18, then we can go on the ride. And now we have one simple else for the other scenario. Else you can't ride. So this simplifies the code quite a bit. Previously we needed to have an if and then an if within that and then an else within that and then another else on the outside, and now it's just as simple: if height is more than or equal to 50 and age is greater than or equal to 18, then you can ride. Otherwise you can't. Alright, another logical operator you can do is the negation operator. So this means not, also called negation. And all negation does is it flips the logic, flips the value around. So not A is true if A is false, and it's false if A is true. So it just gives the reverse of it. And what the truth table for the not operator looks like is if A is true, not A is false. If A is false, not A is true. That's it. So a couple examples of how you might negate some common tests. So like suppose you were testing that x was larger than some number, A. In that case, the negation is that it's smaller than or equal to A. So if you're testing for a number to be positive, x greater than 0, then the negation of that is the same as x less than or equal to 0. So that would be 0 or negative. And so that's the negation of greater than. The negation of greater than or equal to is going to be strictly less than. So if a number is not more than or equal to 5, then it's going to be strictly less than 5. And then the negation of being equal is not being equal. So the opposite of x equals A is x not equals A. So those are just some simple negations that you might run across. Okay, let's do an example of testing, of writing some conditional programming. So let's write a static method that takes 3 integers as parameters and is going to return the smallest of those 3, and we're not going to use any math methods to do this. So let's get IntelliJ fired up. So here we go. I've got IntelliJ going. I don't want to update it. So I already printed out a bunch of tests. So here we have negative A is -1, B is 3, and C is 10. I just ran, if we take a look at smallest of 3 right now, you know, I just switched the order that I'm passing these parameters in so that I'm testing kind of like what happens if A is the smallest, what happens if B is the smallest, what happens if C is the smallest, and so forth. So I did all the possible orderings I could have done for A, B, and C. And there's 6. There's 3 numbers that I'm plugging in. And so I have 6 tests that I'm doing where I put A, the smallest first, the largest third, and the middle one in the middle, and the smallest first, the largest one excuse me, in the middle, and the next smallest one, and the middle one third, and so forth, okay? And so in all of these cases, what's the smallest between -1, 3, and 10? Well, it should be -1. Smallest between -1, 10, and 3? Well, it should be -1. 3, -1, and 10? -1, and so forth. So we expect -1s to show up over here on the left if we wrote our program right. So let's write the method that's going to find the smallest number between those 3 numbers. Okay, let's start kind of breaking this problem down. So we know that if A is less than B, we can then compare A to C, and if A is smaller than that, we have found our smallest value. And our smallest value would be A. So at this point, A is smaller than B, and A is smaller than C, so A is the smallest. A is the smallest. Now, what do we know right here? Well, we know that A is less than B, and A is not less than C. So that means C is less than A. And since A is less than B, C is less than B. So that says that C is the smallest here. So we're going to put our else and return C. Okay? So we've got both scenarios now where A is the smallest and C is the smallest based off of C being less than A. Now, what happens if A is not less than B? So now we know that B is smaller than A. And so if B is smaller than A, then we need to compare B to C. So now we know that B, at this point, if B is smaller than C, we know B is the smallest. So we're going to return B. And then the last possible case is that B is not smaller than C, but it's smaller than A, so that means C is the smallest in this case. And once you've got we've broken it down into those possible paths, we've found all the paths, and and we've covered all our bases. All right, so here A is less than B, so it's kind of further left on the number line. Here A is less than C, and so therefore A is the smallest. Here C is less than A, so C is further left than A, which is further left than B, so that means C is the smallest. And now let's look down here. Now we know B is less than A because A is not less than B. Well, it's really less than or equal to. And then here we know B is less than C. And so B would be the smallest. B is the smallest. What do we know here? C is less than or equal to B, and so C is the smallest. Because B is smaller than A, and C is smaller than B, and so then C is the smallest. Okay, let's go ahead and print these calls out and see the results. Because in all cases, we should have -1 as the answer. And we do. So we wrote our method correctly. All right? So that's how you can find the smallest of 3 integers by comparison. And guess what I'm probably going to ask you to do is to find and print out the largest of 3 integers. Okay, let's look at another example. This example we're going to call blackjack because it's based on the game of blackjack. Given 2 integers that are more than 0, we want to return which one is closest to 21 without going over, because that's the point of the blackjack game. And if both of them are over 21, then we're going to return 0. So that's our method, blackjack. So let's fire up IntelliJ again. I gave a bunch of examples up here, and let's go ahead and write the code for this. So we need to see kind of like what scenarios do we need to break these into. Well, let's handle the both going over first. So let's handle both over first, because that's an easy one to think about. Well, when do we want to return 0? We're going to return 0 if A is more than 21 and B is more than 21. That's both being over. Then we return 0. Okay, so then what do we do in the other case? Well, we know what to do if A is over 21 still. Because if A is over 21, then we would return B, because A went over and B is still under, so we're going to return B. And then if B is over 21, if B is over 21, then we'd want to return A's value. And the reason why we're able to do these is because at this point here, we know at least one of A or B is valid, is under 21. Because we wouldn't have gotten to this else otherwise. And so in this case, we know that B is the valid, B is under 21. And in this case, we know that A is under 21. And so then there's 2 other possibilities, and that's that they're both under 21, and then we want the bigger one. So if A is smaller than B, we're going to return B, which is the largest one. And then the last case would be that B is smaller than A, in which case we're going to return A. So here, both are under 21, so return and A is less than B. Here, both are under 21, and b is less than or equal to a. Okay, and so at that point we found our biggest less than 21 number. So let's go ahead and run the program and see if we pass all of our tests. So in our first case, I passed in 19 and 19, so we gave it two values that are the same and both under 21, and we got 19 as the answer back, as expected. The next case, we passed it 19 and 21, and we expect 21 to be the answer, and we got 21 as our answer. The next case, we passed it 19 and 22, we expect 19 to be the answer, and that's what we got. We passed 21 and 22, and we expect 21 to be the answer, and that's what we got. And then the last one, we passed both over, and we got 0 as a result. And that's an example of the conditional programming. It takes a long time and a lot of trial and error to get conditional programming right, and you just have to kind of throw yourself into the deep end with it and start messing the logic up and banging your head against the wall, and it's something that everybody goes through, and it's frustrating, but at the end of the day, once you catch all of the logic cases, I think it's a rewarding experience. So there's a couple of practice hits you can test yourself on the OneNote. If you go to the practice it in the content library, I'd suggest working through a couple of those. And this Thursday, we might do a small quiz about some of these practice hits in conditional programming. So just let me know if you guys have any questions. And we're going to practice more with conditionals this week and next week. All right, I'll see you in class.